Alright, geometry. Today we're going to be doing lesson 11-7, which will wrap up our chapter 11, areas and volumes of similar figures. So now remember when we did the perimeter, where it was just A over B, area A squared over B squared. We did that last chapter. Well, now this chapter we're throwing in volume, which is A cubed over B cubed, which makes sense. Regular units, square units, cubic units. So that makes sense. So let's say we're given two volumes, a volume of a small and the volume of the large. They want you to find the ratio. Okay, so first thing I'm going to set up is the ratio. So this is going to be 250 over 432. And remember, volume is A cubed over B cubed. Okay, I'm not going to cross multiply or anything. I'm going to simplify it. So I'm going to take out my calculator. Okay, taking out the handy dandy calculator. I'm going to type that ratio in. 250 divided by 432. Because I'm going to simplify this the fast way using technology. Okay, I divided it out, and then I go to math, frac, putting it into fractions. It is 125 over 216. So when I simplified that, I got 125 over 216. What's the cubed root of 125? What number times itself 3 times gives you 125? It's 5. What number times itself gives you 216? 6. 5 times 5 times 5 is 125. 6 times 6 times 6 is 216. So there is my perimeter, or my similarity basic ratio. And that's what they're going to want you to find for some of these. Okay, when you get to problems like number 11, they give you your two surface areas. They give you the volume of the large. They want you to find the volume of the smaller. Well, the first thing, since I have my two surface areas, I need to find the similarity ratio. So I'm going to set up this ratio right here. 248 over 558. Okay, I'm going to do the same thing. 248 over 558 gives me 0.44444, and then I sit there and I do second frac, or I do math frac, sorry, and I get 4/9. Okay, 4/9. So then what I do, if this equals 4/9, well, what's the squares then? What's my perfect squares? 2/3. So therefore, my similarity ratio for this one is 2/3. So when I'm trying to find the volume of the smaller, I am going to set it up, this equals 2/3. Okay, so I'm going to set it up as another ratio. So I am going to say that 2 cubed over 3 cubed equals the volume of my small over 810. Now I'm going to cross multiply. 8 times 810 divided by 27. 8 times 810 divided by 27. I should get 240 for my answer. And that's the volume of the small, 240 inches cubed. Again, you're cross multiplying. 810 times 8 divided by 27. You get 240. Okay, that's the volume of the small. I'll just double check it. 810 times 8 divided by 27. Yep, 240. Okay, so that's how you do those. When you get down over to the cubes, same thing. We're going to set up our ratio. So we got 27 over 64. Now remember, this was A cubed, B cubed. So these are perfect cubed roots. What's the cubed root of 27? 3. Cubed root of 64 is 4. So there's my similarity ratio. Now, they give you the surface area of the larger. We need to find, or the smaller, we need to find the surface area of the larger. So again, set up your ratio. This would be 3 squared over 4 squared, because that's what surface area is. Over 63 surface area of the large. Cross multiply. So it'd be 63 times 16 equals 9 times the surface area of the large. I'm doing it a little bit better on this side so you can see the work that I did. So 63 times 16 is 1,008 equals 9 times the surface area of the large. Divide by 9 and I get 112. What's the units? Meters squared is the surface area of the large. Okay, pretty easy assignment, easy to go through it. Again, don't make it difficult, not a bad assignment at all. So there it is, perimeters, areas, and volumes of similar figures.